All right, we're going to be working on word problems, and I will remind my students that for word problems, there are really only 4 points that are interesting that get asked on about parabolas, quadratics, and the first one is where does it start? And that's when x is equal to 0. Where does it end? And that's where y is equal to 0. That's one of the zeros. That's the bigger 0 for solutions. And we also call these roots. We haven't used that yet. But roots, solutions, zeros, these are, and you'll have one other solution over here. But the ending point is obviously the bigger, the larger, greater solution. And then you have what is the maximum or what is the minimum, and then you're asking for the and here where or when is it maximum or minimum, and then we're looking for the x value for the vertex. So here we have the vertex, and here we want the y for the vertex, x for the vertex. So there's really only 4. most word problems in math revolve around this one. That's kind of because of in real life we know where this is, so it's not very common for us to ask about this, because in real life we can see where things start, and it'll ask how high did it get, or what time was it higher. In the Army, in the Navy, when you're shooting things follow this this projectile path, so if you're using artillery, you want to know where it's going to drop, so most of the calculations in the Army and Navy end up over there. But let's go ahead and look. Okay, so our first one says the power generated by an electrical circuit in watts as a function of the current Z in amperes is modeled by blah, blah, blah. So I can see this is amps, and this is watts. So this is the current, and this is the power. And I can see when x is 0, this is going to be 0. And we can see that the negative, so it's going to open down. So we're going to have something that looks like that. Question is, what current will produce the maximum power? So what current, here's the current, will produce the maximum power? So it's asking, where is the maximum power? What current produces the maximum power? So we want to know this here. We need to find the x for the vertex here, and one of the ways we can do that is by factoring. So I think I'll do that first. So we're going to find the zeros first, and then I'm going to use those and the average of those to find this x value. So I have negative 12x squared plus 120x is equal to 0. I'm going to factor. I'm going to divide by -1, I think, and factor out. So I'll get x times 12x minus 120 is equal to 0. So I know the solutions for this are x equals 0. We know that already. Or 12x is equal to 120, or x is equal to 10. So the other one over here is 10. And the average is going to be 0 plus 10 over 2, or 5. So at 5 amps, we get the maximum power. It didn't ask us what that power is, but we could just put that in, put 5 into here, and 300. Okay, let me go ahead and work on this again. All right, so an object is launched from a platform. Its height in meters, x seconds after launch, is modeled by So here I have time and height, and we have our starting point here, and it's negative on the x squared, so I'm going to go down. That makes sense. We have an object being launched from a platform. Here's the platform, goes up, and then it comes down. What is the height of the object at the time of launch? At the time of launch, so we want the start. And start is when x equals 0, and this is really easy to calculate. So x squared is 0, x is 0 plus 60, so it's going to start at 60. Didn't have to do any calculation for that, basically. Okay. Marquise has 200 meters of fencing to build a rectangular garden. The garden's area in square meters as a function of the garden's width is modeled by what's the maximum possible area. Okay, so we've done these before. Here we've got some fence, and we've got 200 meters of fence, and we're going to put that into a rectangle, and we're going to try and figure out what is the area, and we want to know what the maximum area is. So the model for this is x is width, and y is area, and I can see that width over here is when width is 0, the area is 0, and then it comes up and goes down like that. And we could use the same method that we used last time. Actually, I think I'll do that here, and I'm going to save my other method for our next problem. So then we're going to have to find the average, and that's going to be the x, and then we want to know what is the maximum area. So asking what is the max, so we'll have to figure out the x value of our vertex, and then figure out the y value of our vertex by plugging in. So we've got negative x squared plus 100 x, and we're going to solve for the zeros or solutions or roots by setting y equals 0. And we end up, I'm going to factor here, I'm going to divide by -1, factor, I'm going to end up with, so we can see x is 0 or x is 100. So 100, y is 100, 0, because if we take this fence and we go 100 meters this way and 100 meters back that way, then we have 0 on that side, and our area is the same way. If we have 0 going this way, then we have 100 going this way. And we really can't be bigger than 100, can we? Because we have to connect the fence. Okay, so then what's the where is this vertex? This vertex is going to be halfway between, which is 50. You can see that the average of 100 is 50, and then we're going to have to plug 50 into this up here. So we've got negative 2,500 plus 5,000 equal to 2,500. Is that right? 50 squared, 2 zeros, 25. Yes. Okay, so we're going to have the maximum y is going to be 2,500 square meters. Okay, last one. I'm going to try and use a different method to solve this one. An object is launched from a platform. Look at the platform again. Its height in meters, x seconds after launch, is modeled by how many seconds after launch will the object land on the ground? Oh man, I missed my chance. Does not ask us. That's okay, we can still use. We're launched from a platform. Okay, here's the time, and here's the height. Okay, and it's asking how many seconds after launch will the object land on the ground? So we're asking about that end time where y equals 0. So we're going to try and find the solutions to this. I'm going to go ahead and use the quadratic equation. I was going to use the quadratic equation to get the vertex, but I was saving up. But I'll show you how to do that in a second. So we have negative 5x squared plus 20x plus 60. I'm going to divide everything by, and we're setting that equal to 0. I'm going to divide everything by negative 5 to make everything x squared minus 4x minus 12 is equal to 0 divided by negative 5 is still 0. So let's see, my a is equal to 1, my b is equal to negative 4, and my c is equal to negative 12. I'm going to have negative b, so that's going to be 4, plus or minus square root of b squared, so that's 16, minus 4 times a times c all over 2 times a. Okay, so if we needed to find our vertex, we could just find our vertex right here, which is 4 divided by 2, and that's going to be 2. So our highest point is 2. So we can use quadratic formula really easily to find the vertex. But we're not going to do that. We're going to find this. We're going to find this greater solution here. So we don't really need the minus. We just need the plus. The lower solution. So I have 4 plus square root of 16 plus 48 is 64 divided by 2. And this is 8. 4 plus 8 is. That right? 4 plus 8 is 12 over 2 is 6. So our 0 here is at 6 seconds. And then we can go 4 back here, and we can go 4 back here, and we go this where it would have started if it had been down to negative 2. So let me plug that back in to make sure that's going to give us what we want. So 6 squared is 36, minus 24 minus 12 is 0. Okay, so that looks good. Really don't want to mess up number 4 on here. Okay, so that's how you do quadratic word problems in standard form. Again, there are only really 4 things that get asked, and we can use any of these vertex forms or factoring or quadratic formula. And you saw factors is useful when it's obviously factorable, but quadratic formula is easier when it's not obvious.